One of the most interesting things about boat building is that you're literally breathing life into a pile of lumber and making this beautiful creation that really does have a life and lives on the water.
Sam Devlin is an internationally recognized master boat builder, designer, and teacher. His beautifully crafted wood boats ranging from 40-foot power cruisers to 7-foot dinghies have fulfilled the boating dreams of numerous people around the world. In this video, Sam shares his knowledge of boat building to help you more easily fulfill your dreams of becoming a wooden boat builder.
Hi, I'm Sam Devlin. I've been a boat builder now for more than 20 years, and I've always used a boat building method called stitch and glue. What I'm going to show you is an easy way that with a minimum number of tools, you can build yourself a 7.5-foot dinghy that we call the Pollywog, and I know you're going to be successful. This is the Pollywog, the boat we're going to build. She's 56 pounds. She'll carry 2 adults. She's got a built-in stowage compartment in the seat, and you can fit her in the back of a pickup or even on your car top. We're going to build the Pollywog using the stitch and glue boat building method. It doesn't require any molds, and simply all you do is cut out 2 bottom panels, 2 side panels to a specific shape, a transom. Then we're going to clamp those panels together with wire stitches. That's the stitch part of the stitch and glue. And then we're going to glue those panels together with epoxy and fiberglass cloth reinforcement. When we're done, we'll have a light, strong boat, just like the one here. A couple of nice things about the Pollywog project is you can build it by yourself in a couple of weekends, but if you've got some family or friends that want to help, you'll be able to have even more fun, and you can help show them the joy of building boats. And it isn't going to take a fancy tool list to be successful with this project. These are the tools that we're going to use to build this project: a circular saw, a hand saw, a drill, a block plane, a random orbit sander, a sheetrock square, a compass, a plumb bob, as many C-clamps as you can get, a chisel, a measuring tape, hammer, and a set of lineman's pliers. I've produced this video to show you how really simple stitch and glue boat building can be, and I want you to be successful with your boat building projects. The best way to do that is to watch this video clear through from start to finish and get an overview for the whole project. Later on, you can go back and check specific parts of it for the details that you need, but if you just watch the video through, you'll get the idea of how simple and basic this process is. Now let's go to our blueprints and take a look at the specifics of this boat. The blueprints of the Pollywog consist of about 4 basic pieces of information. One of them is the views of the boat, both a top view and a side view of the boat. The second one is it has a materials list, and the materials list states which materials you need in order to build this boat. Third one is a parts list. That says what each of the parts of this boat is and what they are made of. The fourth part is the actual panel expansions or the plates of the boat. This is the bottom panels and the side panels that are dimensioned, and all we have to do to build this boat is to scale these up and to lay them out on our full-size plywood sheets. Well, with that described, let's go up and get our materials put together and let's start building this boat. There, that finishes the marking of these stations. Now all I've done is I had hooked my tape measure over the edge of the panel, and across the length of this panel I've marked every 12 inches. Those are my station marks. And then I took my drywall square and I carefully hooked that over the edge of the panel, and I've drawn a perpendicular mark, the width of this panel on each of these stations. I've also gone through and marked which stations are which. So 0, 1, 2, 3, 4, and those marks are identical with the marks that I have on my plans. Now I'm going to actually lay out the shape of these panels. This is the guts, and this is the essence of lofting. And when we do this, we're going to use a simple rule that's been used for hundreds of years in boat building, and it's called the feet, inches, and eighths rule. And what that means is you're going to see three numbers. And those three numbers always correspond with feet is the first number, inches is the second number, and eighths of an inch is the third number. If I see a plus or a minus added onto that, that means plus a 16th or minus a 16th. So if I look on my sheet of blueprints, and I check station 1, and this is my bottom panel side, I see a number which says 182. If I hook my tape measure over the edge of the panel, I come in 1 foot, 8 inches, and 2/8 of an inch, and I make a mark. If I check station number 0, I see it says 164. So 1 foot, 6 inches, and 4/8 of an inch. And I'm going to continue doing that for all of these stations. There. I finished driving all these nails on those marks that we made earlier on each of these station lines. Just lightly tap them into place. I'm not trying to drive them through the plywood. Now I'm going to take a nice straight grain piece of wood on a fairly bendy piece. This is called a batten. It's a little bit longer than the line that I'm going to be drawing. And what I want to do is I want to have it held up against each of these nails and bend around. The easiest way to hold this batten in place is to just simply drive a small brad behind the batten. I want to make sure I don't drive it through the batten because that'll affect the fairness of that curve, and we don't want to wreck our batten for future work. Now I want to make sure that I step back and take a look at the fairness on this batten, and what that simply means is I want this to have no definite bumps in it. It has a nice sweep which mirrors what we did in the plans. And now if I place my hand on top of it so that I don't shift it out of column when I'm drawing up against that, hold my pencil quite vertical, I'm going to draw a line which defines the edge of that panel in between each of these nails. And I'm going to do that for the length of this side. Well, now that we've marked out both our bottom and our side panel, and I've pulled the nails out that were along my station marks, I now want to cover what we're cutting this boat up out of. This is 1/4 inch marine grade plywood. And if you will note, this bottom panel and this side panel, if I lay two sheets one on top of another and I clamp them together very carefully, I can cut both of these bottom panels and both of the side panels out at one time. And I'm going to do that. So I've already put a clamp on the other end. I'll clamp up this end. And then I want to take a skill saw and get it ready for the cut. You will want to set the depth on your skill saw to a level to where the teeth are just barely sticking below the depth of the plywood that we're cutting. If it sticks down too far, you're taking a risk of having a kickback, and we don't want to do that. So for safety's sake, just have your teeth just barely clear the bottom of the plywood. I also want to make sure that I put on a pair of safety glasses, and I want to put a respirator on. And as soon as I do that, I'm going to start my cutting. I have found that you can cut around a radius with a circular saw by lifting up on the back end of the saw and kind of attempting to scissor your way around the radius. Some people might want to use a jigsaw here as it'll cut around this radius a little bit simpler. When you're cutting with a circular saw, be sure you cut to the outside of the line, and then we'll take our block plane and we'll hand plane it down to the line later. You'll have to use a hand saw for this cut. Well, now I want to show you how to lay out the transom. And what I did was I used a base line as a factory edge on the bottom of my plywood panel. And with a framing square, I drew a center line perpendicular to that base line. Then I needed a couple of heights. I needed a height at the chine edge, which was 3.5 inches. And if I measure up and make a mark on both sides, then I can draw a line connecting that, clear through my center line. I need another point, and that is the shear. So I'm going to come up 14 3/8 of an inch, and I'm going to make a mark on both sides of my center line. And then I'm going to take a straight edge and draw a line through that also. Once that's done, I need my widths. And my widths would be measured from the center line over, 20.5 inches, make a mark, and 17 3/4 inches, and make a mark. Then with a straight edge, all I've got to do is connect those marks from the center line up to the chine mark, and from the chine up to the shear mark, and draw those in. And I'll do that on both sides. When that was done, I took some small brad nails, put one at the shear on both sides and one at the center line, bent a batten into place, and marked out the crown I needed for the transom. Well, we've cut out our 2 bottom panels, our 2 side panels, and our transom. I've got my 2 bottom panels in front of me. I've lightly clamped them together, and I want to take a block plane and work these panels down to my lofted fair line. The saw cut could be a little uneven, and I want to make sure that I try to take the humps off and even out the valleys as much as I can from the unevenness of that saw cut. So it's best to stand back, sight along the length of it, and then with long, smooth, even strokes, work your block plane down the edges of those panels. What we're looking for here is symmetry between the panels. That's the major important feature. There, now I've planed and faired up the edges of my 2 bottom panels, my transom, and my 2 side panels. That fairing up hits the bumps and the valleys from our saw cuts and helps even and make things symmetrical. I'd also like you to note that I kept the edges square on my transom. I did not plane a complex angle on that. We'll end up with a stronger joint in our transom doing it that way. We'll set this aside now, and I want to pay attention now to the keel edge of my 2 clamped up bottom panels here. What I want to do now is I want to plane a 45-degree angle off, roughly halfway through the thickness of the 1/4-inch plywood, on this edge and on this edge. And I want to do that the length of this panel. That's a non-critical 45-degree angle, but it helps give us friction in the stitched up keel joint and helps keep those panels in alignment when we go to stitching them up later on. There, we've got our bevels trimmed, and I'm going to unclamp my panels now. And I'm going to reposition my panels so that those bevels are now on the inside edge. So I'll pull this top panel back, pull this bottom one up, then I want to reclamp up the 2 panels so that they're nice and square together again. And that 45-degree bevels are facing interior now. There, that finishes that up. Now I'm going to turn the panels over, pull them back to where I can work on this edge here. And I want to move into scribing my stitch line. The stitch line is on the keel edge of the 2 bottom panels. And what that is that's the line on which we're going to have our small wire ties, the stitches that fasten these 2 bottom panels together. They're going to be all in line with that. And the rule is I want to do the thickness of my plywood plus 1/8 of an inch. So I'm going to set this cabinet maker scribe to 3/8 of an inch, And then I'll scribe this keel edge of these two bottom panels. There, that finishes my scribe line there. Now I'm going to pick up my drill and I'm going to drill a series of holes along the keel edge, along this stitch line, roughly 2 inches apart, within about 3/4 of an inch of this bow and within about 3/4 of an inch of the transom. Roughly 2 inches apart up in the bow sections. Once you get past the heavy bend and curve in this bottom, then you can move to roughly 6 inches apart in this straighter section where there's less strain on it. Now these holes are going to be what we're going to place our little wire stitches into. So now I'm going to drill these series of 1/8 inch holes the length of the panel. There, now I've finished drilling those stitch holes. I've set myself up with a small kit. I've got a pair of lineman's pliers and some 16 gauge mild steel baling wire. And I've cut those to lengths of about 5 inches long. And I'm going to place these wires in these holes and twist them up the entire length of this keel. Now those wires are simply a clamp to hold these two panels together in relationship until we get a chance to put our epoxy joint in them and bond them together. So loosely, I'm going to twist these up and then I'll come back and retension all of these wires the length of this. What I'm looking for is enough tension to hold the two panels in close relationship to each other, but not too snug as to cut into the wood itself when I spread these bookends apart. Now with all of our stitch wires along the keel edge tensioned, I now want to stand the two bottom panels up and I want to spread them apart just like opening up a book. There's going to be a little creaking and a little noise that's going to happen on this, but that's just the wires stretching into the wood. Now what I want to do is I want to spread this apart to about the angle that I anticipate the boat staying in real life. And I've got a short length of scrap wood, about 20 inches long. And I'm going to place that along the center line of the boat. And with a short length of wire, I'm going to stick around one of my wire stitches in the bottom of the boat. I can hold these two panels apart. I'll twist this wire up like so. And then if I place the handles of my lineman's pliers through there, I can twist this around and create a little Spanish windlass that'll hold this spreader spall in place. Now, my two bottom panels are held apart. You can see a little unevenness in the keel line where one panel is a little above the other. Right here, this panel is a little below and this is a little above. If I want to even that out, it's easiest to take a hammer and just lightly tap alongside of that. That 45-degree bevel that we planed on the inside edge of these bottom panels aids us in that joint. It gives it a little friction. This looks pretty good. I think I'm ready to go on to the next step. Now I want to prepare my two side panels for placing on the boat. I've already clamped them together, and if you would note, I've already pre-beveled this inside face of the stem or the bow end of the boat. And we flip-flop those so that they're inside facing now, just as we did in the bottom panel. And now we're going to scribe their stitch line. I'll set my cabinet maker scribe to 3/8 of an inch, and I'll start at the bow and work my way aft. I'll finish up here in front of the transition joint. Now I can take my drill and I'll drill a series of stitch holes, or pre-drill a series of stitch holes through both of the panels at one time. I'm going to come forward about 1.5 inches in front of the transom, so I've got room to place the transom in, and I'll drill those series of holes. I want to go about 2 inches apart at the ends of the boat, and in the middle of the boat I can spread it out to about 6 inches apart. Okay, now I've prepared my side panels to go onto my bottom panels. This is the transition notch up forward here, and as you can see, it lays up on top of the bottom panels in this forward 7 inches or so, and then it runs down alongside of the bottom panels the balance of the way. What I've done is I've measured back simply the length of this notch. Using my hand saw, I make a small saw cut. Then with my chisel, I chisel at the same angle as the side lays in relationship to the bottom. I chisel up into that saw cut. Next, I take my block plane and I finish up the rest of that beveling on the chine, clear back to the transom. Well, I've brought my son Cooper in to give me a hand stitching these side panels onto the boat. This is one of the areas that it's really helpful to have a helper assist you, because what you have to do is you have to keep this panel held very close and tight in relationship to the bottom panels as we're stitching it up. He can move the panel up and down and in and out as I'm moving along, and that really helps me a lot. So let's go ahead and start fastening now. There. Now I've already fastened my sides onto the bottom of the boat, and I've now placed 2 wires on my transom that are helping me stitch that in relationship to the bottom of the boat. I want to make sure that I keep my orientation of my center line pointing straight down and directing into the keel line of the 2 bottom panels. I don't want to let it shift to either side. Next, I'm going to place a wire about halfway out on the bottom panel and another one out towards the chine edge of that. I'll stitch that side, do the opposite side. Then I want to place a wire at the lower edge of the side panel and one up at the top here, and I'll do the other side. When I'm satisfied with that layout, I'm going to move on to my next step. Well, now I've got, as you can see, my sides are stitched onto my bottom panels. My transom is stitched into place. The boat's still not quite looking like I want it to look, but nonetheless we're stitched up and I'm pretty happy with it. The next step is putting the spreaders in place. From your plans, they're going to give the locations on them, and what they do is they really open up the magical part of stitch and glue boat building, and that is, this is when the boat really springs to life for me. It really starts looking like the boat I had envisioned in my mind. I'm going to put another one up here. Now I want to step back and I want to take a look at this boat and see the shape and see what I've really created here. And I'm happy with it. So the next process is I want to check for squareness to make sure that before I epoxy tab it, that I'm happy with everything. And the way I do that is I take my tape measure, hook it over the stem, and I draw back diagonally to the corner of the transom. This dimension should be identical to the one on the other side. If it's not, I can adjust it by shifting the transom a little bit by pressing up on one side and down on the other side. But if those dimensions are identical, then I'm ready to go on to epoxy tabbing. Well, welcome to Epoxy Central. Over here I want to discuss the epoxy resins that we're going to use to bond together our stitch and glue boat. I've got resin and I've got catalyst, and I've got some other stuff that's going to help me handle this epoxy resin. I want to touch on safety now. You need to keep epoxy resins off of your skins. What's going to help you do that is disposable safety gloves, a respirator to keep you away from the minor amounts of fumes that they have, some safety glasses in case the epoxy splashed up during the mixing process. Those are all going to help. If you get epoxies on your skin, you want to make sure that you get your gloves off, use some waterless hand soap, and get yourself cleaned up. What you need to avoid specifically is using aggressive solvents to do this. You don't want to use lacquer thinner, acetone, or any of those types of solvents to try to clean this epoxy off of your skin. They tend to strip the oils off of your skin, and you have a lot of your own personal protection is based on those oils in your skin. So don't use those solvents. Use just waterless hand soap and clean yourself off. Now, every epoxy manufacturer is going to have a different mixing ratio that they're going to recommend. In the case of this manufacturer, this guy wants 2 parts resin to 1 part catalyst. Okay, I can arrive at that ratio 2 different methods. I can either use metered mixing pumps, which I have here, or I can use a graduated cup, and I can literally measure the amounts of resin to catalyst and the proportions there. So as long as I've got that proportion mixed properly, then the next thing I want to cover is actual mixing of the epoxy itself. What you want to make sure is you stir the epoxy up very well, scrape off the sides of the container, scrape off of the bottom, and then mix it again. You literally cannot mix it too much. Once I've got my mixed epoxy and catalyst, and it's stirred up, then I can add my filler materials. And in this case, I'm using wood flour. And wood flour is particularly nice for this kind of process because it's wood colored. The density is very similar to the density of the wood itself, and I think it makes a very excellent filler material. I've mixed this to a rough peanut butter consistency, and as you can see, it's not really dripping off of my stir stick. What I'm going to do now is I'm literally going to tack weld the boat together. I'm going to place a small fillet of epoxy and wood flour in between each of our wire stitches that are holding the boat together right now. And I'm going to let that cure up overnight, and tomorrow morning we'll come in, I'm going to pull the wire stitches out, and then we'll proceed to finish welding the boat together with our epoxy resin and glass cloth. So I'll put my mask on and we'll get going. Well, I've let my fillet material cure overnight, and you can see all the wires that held this stitch and glue boat together. To get the wires out, I first untwist each of the stitches. Then with my pliers, I trim off the excess length of wire sticking out of the joint. Then using my pliers like a lever, I clamp onto the wire and I roll the wire out of the joint. If I've got a little fillet material on the inside of the wire, some epoxy, I can heat release that by using a propane torch, and that'll cause the wire to be able to come out. Now that I have all the wires out, I'm going to sand all of the joints of this boat and smooth down my fillets so that I'll have a nice clean area to work in. Now I'm ready to glass the interior seams of the boat. I'm going to use 6-ounce by 4-inch wide fiberglass cloth tape. Roll out the tape and measure the lengths that you need for each of these joints. Now I'm painting out all the joints that I'm bonding with about a 6-inch wide band of mixed epoxy resin. That's to allow the epoxy to soak into the wood as much as it wants to give me a better bond for the glass cloth. Using my fillet material, I'm now paddling the material into the joint to make a nice, smooth, even cove. Next, we lay our first pre-cut layer of glass tape into the fillet material and smooth it down. Next, I paint the first layer of glass tape with epoxy resin, saturating it until it's clear. You'll want to stagger the second layer of glass tape so that it overlaps the first layer. Now I'm saturating the second layer of glass tape with epoxy resin just as I did in the first. The third layer of tape, once it's set into the joint, won't require much epoxy to saturate it because it absorbs the excess epoxy from the other layers. You want to make sure that you get all of the air bubbles possible out of the glass tape by smoothing it out or coaxing it with your brush. After my epoxy is cured on my interior taping, I want to come in and with 80 grit sandpaper, I want to lightly feather the edges of that glass tape, and I want to knock the sheen off any epoxied surfaces. This is my rear athwartships bulkhead, and that's at the rear seat of the boat. I've got another one at the forward seat of the boat. I've already epoxy and bonded this in place, so now I want to move forward and show you how to do that. From the plans, I've cut out my part already. The only thing to note here is I've got a notch for the inwale on either side of it, and I've got an orientation, although it's faint here, for the center line of this. From the plans, I measured aft 48 inches, which is the placement for this bulkhead, and I dropped a plumb bob in 3 points from the center line down to the keel and out at each chine. That's where this bulkhead goes. Now for installing this, all I want to do is make sure that I paint out the end grain of this part with epoxy resin and any of the mating area in the boat so that we make sure that we don't have a resin-starved joint. Then I can drop this down and pin it in place with either screws or a couple of light nails. Mix up epoxy fillet material and fill it forward and back, and then a single layer of tape to help reinforce this in place. There, that finishes up my stern knees. I've got one on either side of the transom of the boat. I used 2 screws on the back side and 2 on the sides to pin them in place, and then an epoxy wood flower fillet top and bottom to permanently bond that in place. I've done the same thing up forward in the bow of the boat for the breast hook. Now for a boat building detail, I like to put just a little bit of an angle on those stern knees going up like so, just to make the stern area look a little bit nicer. It's a small detail, but it will make your boat look a little better. Now with that done and bonded in place, I'm ready to fit my inwale and get it glued in place. The inwale is a batten that's glued onto the inside of the sheer of the boat on each side. There, I've got the inwale in. Now all I've done is I've simply fit it, mixed up a small slurry of wood flour and epoxy resin, much more to a honey-like consistency than to a normal wood flour paste. And by painting both the mating surfaces of the inside edge of the inwale and where it's going to place on the boat, I was then able to place it stern first, moving forward, and with the assistance of a couple of C-clamps, I then pinned it or screwed it from the outside in with some small number 6 screws. Once that was set up and I was happy with how tight it squeezed up, I cleaned it up and I'm ready to move on. To get the boat ready for fiberglassing, I'm using a block plane to smooth down all of the joints of the boat. Next, with my random orbit sander, I'll radius all of the joints and smooth them down. I finish this process by smoothing down all of the joints one last time by hand sanding. Now I'm rolling out my fiberglass and roughly pre-cutting to size. I want to leave a little extra here so that it'll be easy to work with when I actually start applying the epoxy. With epoxy fillet mixture, I now am puttying all the imperfections on the hull. Before I lay the fiberglass out, I want to make sure I paint all the seams of the boat with epoxy resin first. Next, I pull out my pre-cut panel of fiberglass and smooth it out over the hull with my hands. You'll notice I'm only working one half of the boat at a time. Pour the epoxy onto the cloth and spread it out with a squeegee. It's better to start at the top and work your way down. I want to be careful not to press too hard with my squeegee and move the glass cloth panel. Wherever there's an overlap, use scissors to cut small darts to help the cloth lay smoothly. The second panel of glass cloth overlaps the first panel at the keel and stem area. We want to make sure that we have 2 layers of glass cloth overlapping each seam of the boat. At the chine and at the transom, we need to add another layer of 4-inch tape to give us our 2 layers total. Once the epoxy is cured hard on my sheathing, I want to come in and lightly sand the boat. To help do that, I want to cut the greasiness of the epoxy curing reaction off with just a normal water wipe down. I want to lightly sand the exterior of the boat with 80 grit sandpaper just to create a finish that I can stick other epoxy to for my finishes. When sanding, you have to hand sand the chines and the edges. Machine sanding will cut through the glass cloth. This is the skeg. It helps the boat track straight when you're rowing it or when it's being towed. Now what I've done is I want to introduce a concept of using scrap stock to fit a part. I'm going to practice my fits then on stuff that's not expensive before I move it and cut my final part out. Now in this case, I've made a finished template. And the way that I've done that is I hold my scrap stock up onto the boat with a pencil compass. I set the compass a little bit higher than the largest gap that I've got. Then I go up forward to where I'm going to start fitting the part, and by holding the compass very vertically, I draw that lengthwise along this edge. When that's done, I can take this scrap stock off, go over to my workbench and cut it out, and bring it back over here and fit it finally into place. When I'm satisfied with that, then I can go and cut out my expensive stock. The gunnels are battens glued to the exterior of the boat. They, along with the inwale, add rigidity and reinforce the shear of the boat for the strains of rowing. You can see I've done some detailing on the ends of the gunnels. I want to just make sure that's symmetrical side to side, and it's strictly a detail. It makes them look a little bit nicer. Those gunnels were fastened on by screwing from the outside in, and I countersunk my screw holes. Then I've gone ahead and taken wood bungs and glued them in place with the grain running lengthwise. Let that glue set up, then I've trimmed them flush. The final thing I've done was to block plane the top of the gunnel smooth and to do final shaping with hand sandpaper. Earlier, I placed the bulkheads for the seats, and now I'm going to place the seat tops. Now for my rear seat, and in fact for my forward seat, all I want to make sure that I've got some cleats to fasten the seat down into, and I'm going to screw it in place. I want to pre-epoxy seal this compartment out, place my styrofoam for flotation, and then the final thing is make sure I've got a couple of small vent holes drilled in it so that this compartment can vent out, and make dang sure that I've pre-sealed the bottom of my seat. Now she's ready to screw down in place, and I'll fill it the top of this. With everything fit on the boat, the last thing I've got to remember is to roll a coat of epoxy resin on all surfaces, inside and out, to seal up any bare wood especially, and to level out anything else. Once that's done, I'm ready to start my painting and finishing. For whatever method you use to paint your boat, follow your paint manufacturer's recommendations for applications. That's going to yield you the best results.
One of the greatest pleasures of boat building is being able to stand back and look at what you've created. By following the instructions presented in this video by Master Boat Builder Sam Devlin, you will be able to create a polywog like this, a sturdy, lightweight dinghy that will provide you years of boating enjoyment. For many, the polywog is only a beginning of quiet hours spent rowing on the bay, and the beginning of numerous boat dreams that will come to life in your shop. In the words of Sam Devlin, bring only your dreams and enthusiasm. The boat you build will strengthen and reflect your inner spirit. And like me, you might find that designing and building wooden boats is a fine thing to do with one's life. For more information or to order sets of plans, you can write us at Devlin Designing Boat Builders, Inc., 2424 Gravelly Beach Loop Northwest, Olympia, Washington, 98502. Or call us at area code 360-866-0164. Or visit our website at www.devlinboat.com.